gas training, setting up and testing gas valves. My name's Alan Hart and today I'm back at Viva Training Academy and we're going to show you how to set up and test different types of gas valve. We've got loads of gas valves here and we've got the expert trainer, we've got Roy back, Roy's been a trainer for a long time, a lot of years, and he's an expert on testing with a multimeter and testing gas valves. So he's going to go through all different types of gas valves, explain different gas valves and how they work, and hopefully from this video I'll give you a better understanding on gas valves in boilers, in combi boilers, etc. So yeah, let's bob over to Roy.
This video is for gas safe, registered and trainee gas engineers under supervision. Please comply with the current regulations at the time.
Hi guys, it's Roy Fugler here at the Viva Training Academy over in Halifax, and today we're going to be having a look at gas valves and setting them up, testing them, different styles, different types, what to look for when you're out there on patch and you need to set burner pressures, checking inlet working pressures and things like that. So without further ado, we'll kick off. A couple of weeks ago we did a video about thermocouples, so I'm not going to do gas valves with thermocouples. So the next stage after thermocouples, there was a thing came in called SEDBUT 1999. It basically was about energy efficiency, and what that did, it got rid of pilot lights. So some manufacturers still like pilot lights, but they couldn't have permanent pilot lights, so they had intermittent pilot lights. So I've got a couple of gas valves here that are very similar. They're both Honeywell and they've got intermittent pilots on. So here we've got the gas valve and the burner arrangement. So we've got the pilot here and that's controlled by a pilot solenoid. So when the boiler goes to fire, the pilot light ignites, we get a signal back down the ignition lead, back to the circuit board, that tells the circuit board the pilot's lit. It will then energise the main solenoid and that will allow the main gas to come on. So this particular one, as we can see, we've got two solenoids. We've got the main solenoid and the pilot solenoid, and in the middle we've got the regulator or governor, so that allows us to adjust the burner pressure. We've got two ports. We've got an inlet port so we can measure the gas coming in, and we can measure the burner pressure. Because this was an older style boiler, that's how we would measure that pressure. So that's the burner pressure. So that's that gas valve. This one's off a Baxi Solo. As you can see, there's no regulator on there, but you can adjust the burner pressure on this one. There's a little screw just down there, a little brass screw. That's how you could adjust the burner pressure on that one. So it's a very similar valve. Now the one little trick with these valves is, occasionally one of the solenoids will fail. Now the great thing about some of the older valves, you could actually change the solenoids. You can get the spare parts and you can still get them today. So for instance, if this pilot solenoid failed, it's just a simple matter of replacing it. There's a little spring clip which holds it in, so that's in there. So I'm just going to remove that spring clip. I'm just going to ease it out a little bit, just using a screwdriver. So that eases out, that comes off, that unit will lift out, so we can remove that little solenoid. So that's the old one. So we've got a new one over here. So you can still get them. That's the one, and it's off a Baxi Solo. So that's the part. So I've got one I've already unravelled. So there we go. So all that does, it just slides into this holder. So we'll just pop him in, slide him down onto there, and we can put the little locking piece, just a little lock piece into there. So we've replaced that solenoid. As regards testing, now this is the wiring harness off this particular boiler, so I'm just going to connect this up because then it'll be more real life. So the earth connection goes onto there. We've then got a live connection for the main solenoid and a neutral connection for the main solenoid. We've also got a live connection and a neutral connection for the pilot solenoids. So there are the connections. So if we looked in the manufacturer's instructions, and I've got a sheet here, so this is the manufacturer's instructions, there's a nice wiring diagram and it explains it, and it's also schematic down there. So basically it tells us the pilot solenoid and the main solenoid. The main's on red and the pilot solenoid is on the orange. So if we wanted to test them, that's what we could use. We've also got the fault finding diagram, which is that one. So as we go through, there's a little section down there, check continuity across the pilot solenoid, 1.5 kilo ohms. So that's where we need our trusty multimeter. So I've got my Fluke 114, which is what I tend to use for training. I'm going to pop it onto the ohm scale. I'm just going to check that it's working correctly. I've got OL open line because I've got no connection. Pop the probes together and see what I've got there. I've got around about 0.2, 0.3 of an ohm. So that's just checking that my leads are working. So when I test any electrical component, it's really, really important. Obviously this is on a bench, so there's no power to it. But out on patch, when you're working on boilers, always make sure before you do any electrical testing, you do your safe isolation procedures. We've done that in the past. Refer to TB 118, Technical Bulletin 118, always work safely. So when I'm checking resistance, I would always remove one of the leads. The reason being is if that end is connected to the circuit board, I might get a back feed. So I'm just going to check that pilot solenoid now. So I'm just going to go across those two. And on the pilot solenoid there, I've got 1.519. So that's within the tolerance I'm looking for. 1.5k, so that's 1,500. If I check this one, it shouldn't be too far away from that. And it's round about the same. The main solenoid I can check by removing one of the leads from there. And I can just pop it onto that one. And also onto that one. And on this particular solenoid, I've got 5.29k. And just as a benchmark, we'll check it against the other one over here. And it's 5.1. So there is a slight difference, that's fine. Most manufacturers will give you around about a 10% tolerance on your resistance readings because of variations on the components and things like that. So that's on this type of gas valve. So what we'll do, we'll move on now onto the next stage. Right, so we've just been through this Honeywell gas valve, and this gas valve works on the principle of all gas, no gas. So basically, as we said earlier, the pilot light lights from the pilot solenoid, sends a signal back, the main solenoid opens, and then whatever we've got the burner pressure set to, that's what it runs at. It doesn't adjust, so it's all gas, no gas. So we'll put that to one side. So we've got two further Honeywell gas valves which work on that same principle. These look very, very similar to each other. The main difference is this one's got a traditional type of regulator or governor on there, and the other one has just got a small adjustment screw, so we can alter the burner pressures. We've also got the inlet and outlet ports, so we can measure the inlet pressure coming from the meter, making sure we've got correct pipe sizing and correct gas, and then the burner pressure, so we can set that up dependent on the amount of gas that we need. So on the solenoid, it's a twin solenoid, so we've got 5 pins on there. So we've got 2 pins on V1, so that's for the first solenoid, and then 2 pins for V2, and in the middle we've got an earth pin. On a 240 volt solenoid, you'll always have an earth pin because it's earthed back to the PCB. So when we test these, there's a couple of ways that we test them. So I'll just put this one out the way. So we get this one, and if we test across V1, so I've got my multimeter and I've got it on ohms, I've already tested it. So if I go across the first 2 pins on V1 and I pop that on, I've got 2.8k ohms, so 2,800 ohms. And if I check on V2, I've got a connection on there of 1.3k ohms. So basically, I've got there 1.3, 2.8. So if I check the outer 2 connections, so the outer 2 on V1 and V2, what I'll get is the sum of the 2 figures. So I've now got 4.1, so 2.8, 1.3, that adds up to the same figure. So that's testing that particular gas valve. So that proves that's working. I'll just fetch the other one in and just go through that one to make sure this one's operative. If either of the figures were out or wasn't a good reading, what I would find there is that my solenoid has failed, and unfortunately, because these can't be replaced, I would have to change the complete gas valve. Just a little bit of a recap on electrical testing. So when I'm checking a resistance reading, there's one of three things can happen. One, I can get a true reading within 10% of what the manufacturers say it should be. The other one I could get is what I'm getting when I've got the leads apart, which is an OL connection, open line. That means there's no connection between there. So basically something has broken circuit. So however much voltage I put in there, I'm not going to get a reading. The other one is a really low resistance reading. Anything below 20 ohms, and that's going to potentially blow the fuse. So they can start to fail. The one which is more difficult to find is when they start to drift, when components start to fail. So the reading's outside the 10% tolerance. So if it's going towards the low side, it could be starting to fail and maybe blow the fuse. If it's going towards the high side, it could be that component's not working as well as it could be. It's not always opening. So that's on this particular type of valve. So what we're going to do now, we're going to move that to one side, and we're going to fetch in some modulating gas valves. Right, so now we've moved on a stage, we're on to modulating gas valves. So they're all virtually the same, they're all based on that Honeywell gas valve that we've just looked at, and I'm going to go through them. So we've already seen the main solenoids, the first two solenoids, and they're all exactly the same across these. Now one of the things that I do when I'm fault finding, sometimes I can test at the connection, sometimes I test at the circuit board. I'm a little bit of a geek and I make up little test leads. So this is an old harness that I took off the boiler. So basically I can plug that on there and it's going to test me both coils at one time. So I'm just going to go across the black and the red leads, and I go across the black and red, and as we saw from the previous one, I should be looking about 4,100 ohms, and I'm there 4,200, so again I'm within that tolerance. But this is more about the modulation side. So just to give you a bit of background, why did modulation come in? Well, I mentioned said book, energy efficiency. We started off at minimum of a said book band D boiler. So basically what we were looking at then is making sure we got a minimum of 78% efficiency. So the easiest way I used to explain to customers, if I had a credit gas meter and I had to put coins in and I put a pound's worth of gas in there, I'd get 78 pence worth of heat. Well, the next stage, in gas boilers, we went to band B, minimum of 86% efficiency. So what we had to start doing then was only using the gas that we needed, rather than all gas, no gas. As the boiler starts warming up, we start turning the gas down. Very similar to if you're cooking pasta, you put your water on to boil. As soon as it starts boiling, you put your pasta in and you turn it down. So you're not using as much gas. So what we've got here are 3 modulation coils. How they work is by altering the voltage, and these work on DC voltage, low voltage DC, so that can be turned down, it can be increased or decreased, and that will allow the gas valve to open or close. So in this one's case, that's how we're adjusting it. Now come on to how it's adjusted shortly. Now you might think that these two are both the same. They're not. The green one, that's a maximum of 28 volts. And the white one's a maximum of 17 volts. Different manufacturers use different voltages, but you can still adjust it through. This one is an earlier version which has a little separate solenoid on. Now on this particular one, that solenoid can be replaced, as we saw earlier on the solo gas valve. We could replace that. So I'm just going to grab it from over here. So again, what we've got is we've got the part there, so that's still available, and all we'd need to do to replace that, there's a little clip, which all we do, we just unhook the little clip off this. So there's a little clip there, and that allows that to slide off. So that's the solenoid. Very, very simplistic job, very, very easy to repair. So saving your customers a little bit of money, giving you a bit more kudos. But I'll put that to one side. So we'll look at these two now. So if we go across the modulation coil on this particular one, the green one, Because it's low voltage, it's only going to be a low resistance reading, so we'll check across this one and we'll find the resistance reading on this one. It's about 111.7. So we'll check this other one, and that one's 43. The reason there's the difference is one's working on a slightly higher voltage, the 28 volts, compared to the 17 volts. This particular one, it's stamped on the back there, 14 volts DC. So we'll see what this one's going to give us. And again, just go across the two connections. So this one's 39.6. And just to double check it, we'll see what we get on here. And that's 40. So it's not too far away from that one. So setting these up. So we remove the little plastic cover, and underneath you've got two little brass nuts. There's an 8mm nut and a 5mm nut. Now in a previous video on a Baxi Solo, we actually did the adjustment, but I'll just recap that for you. So when I'm adjusting them, what I normally do, I use an 8mm spanner and a little 5mm nut driver or a 5mm socket, because it's important when we are doing any adjustment that we don't move them both together. We keep one static and onto the other one. So basically the little 8mm spanner goes onto the top, and then the little 5mm nut driver. So the larger 8mm, that's altering the high fire, and the 5mm's the low fire. So how do we get it onto high and low? Well, on these boilers, we turn them on, we stick the hot tap on, because generally they're on a combi, and we'll make sure it goes onto high fire, and we can check that against what the manufacturer's data badge says. To get it down onto low fire, most of these boilers don't have the facility like a lot of the modern ones for the chimney sweep function, where we can push a button or ultra switch to put it onto low fire. So what we do, we just pull one of the leads off, so we're disabling the voltage going onto the modulation coil, so it'll go down onto its minimum rate. And then what we'd do, we'd hold the larger nut and then just adjust, either screwing in to increase or screwing out to decrease, to set the minimum burner pressure. So we can set maximum burner pressure, minimum burner pressure. So they're modulating gas valves. So again, as we had before, we've got the inlet port to make sure we've got sufficient gas coming in, and we've got the burner port so we can set the burner. So the next stage that we're going to move on to is go on to an SIT gas valve, which is on a premix burners. It's a very popular gas valve, is this, so I've got quite a number of models, so we'll go through that next. So we're going to look at the SIT 848 gas valves. Very, very popular in premix burners. So we talked about said book, we talked about band B, modulating gas valves. Then we went to band A, which was pre-mixing, so we're mixing air and gas. Typically the fan either sucks or blows gas into the combustion chamber, and the gas valve is affected by the suck or the blow on the gas valve, so that's what's letting it in there. So we've got various models here. We've got a couple of 240 volt ones and some low voltage ones. I'll come back to adjusting these, because some manufacturers say you can adjust them, some prefer you not to adjust them. I'll come back to that. So when we're testing them, again, very similar to what we had before, where we've got 240 volt and we've got low voltage, we've got a number of pins. So this particular one's off a Worcester, and in the Worcester instructions, it's a Worcester Green Star. So in the Worcester instructions, there's a nice little section there with some resistance readings for your thermistors and things like that. And then there's where we test on the pins. So if we look on this one, we've got a couple of pins at the bottom. What would be the middle pin in the carrier, that's the earth, because it's 240, and a top pin. So we'll have a look on there, and we'll just go through the testing. So first of all, it says the first and the third pin, so the top one and the third one down. So we're going to test across those two. And we've got a figure of 5.86k, so 5,800, and on the sheet it says 6,100, so we're not a million miles away, so that's okay. So the next two is down at the bottom. It's telling us to look for the third and fourth. So on the third and fourth, and we've got 0.900k, so 900 ohms. and in this one's case it's saying 900, so that's absolutely spot on. So that gas valve we know is correct. Now this one's off the Baxi. It's virtually the same gas valve, it's just a different coloured solenoid. So again, I'm going to test the same connections. So if I go across the first and the third pin, and I'm on there, and I've got 6.6k, so 6,600. So that's again what we'd be looking for, it's round about there. So I'm going to go to the bottom pins. Oh no, we've got OL. So that's telling me that that coil has failed. So in effect, that's the reason that I've got this gas valve. It's one, when I was a Baxi engineer, it must have failed, and I've kept it as a test piece. So basically, that's so I can show people how they fail. So what we've got now is some low voltage versions. Again, that's off a Worcester, that's off the latest Baxi 600. This particular one, it's got a little extension piece which goes in, and I've made myself one of these little test leads. So I've got one solenoid on two blue connections, so we're just going to have a look on that one. And on that one I've got 392 ohms. I haven't got the figures for this one, but if I refer to the manufacturer's instructions for this particular boiler, that would give me the right figures, or contact their technical help desk, and 177 ohms. If I check the Baxi 600 one, I have got the figures for that, because Baxi have made a manual with it in there. So this is the wiring diagram for that. And then if I just check across down here, I've got on there, I would be looking across the outer two pins of 43 ohms. Because these fire up together, I'd go across the outer two pins, so 1 and 4, and I've got 43.1. So I know that that's perfect, that's absolutely set up correctly. So coming on to this purple one, again this is low voltage because it tells me down here this is a 24 volt one, and I go across the outer two pins on that one, so I'm checking both solenoids at once, and that's 228. Again, I'd need to look at the manufacturer instructions to make sure that that's correct. So setting these up, Baxi for a long time have always said, providing the engineers had correct training, got the correct equipment, so flue gas analyzer, Baxi will allow you to adjust the gas valves if necessary. So how would we adjust a gas valve? Right, I've got a little sheet here, we'll put this up on screen so you can follow it through. We've got a couple of adjustments. We've got what's called the zero adjustment. That's what we traditionally call the governor. So we've got a governor screw. So as we learned before, if we screw the governor screw down, we increase the amount of gas. So what we're doing is we're letting more gas through. And then we've also got what's called the throttle screw. So the throttle screw, or the ratio adjuster, that one's there. That's allowing more or less of the mixture through. So the first one's adjusting the mixture, and the second one is letting more or less through. So the one thing to be careful of on here, this is one of the reasons that was changed to a 4mm Allen screw, is that underneath it's a 4mm Allen screw adjustment. So we need a 4mm Allen key. So I use these Allen key screwdrivers. Now if I'm wanting to increase the amount of gas, so increase the amount of CO2, I'm going to screw that down, and decreasing is up. And then that's on my minimum adjustment. On my maximum CO2 adjustment, I've got a little throttle screw. So what I'm doing, I'm screwing that in and screwing it out, and that's adjusting a little flap inside there that's letting more or less gas through. So that's to set up my maximum adjustment. We will in the future be going through how to adjust the gas valves on a live gas valve using flue gas analyzers. So that's just a little taster of what you can do on those. So that's an SIT848. As I mentioned earlier, it's used by a lot of manufacturers. I know for a fact Baxi's been using this style of gas valve for nearly 20 years, going back to the original Power Max, the range Power Maxes, and going through to a lot of their other products. It's quite a reliable gas valve, very easy to set up and adjust. As I also mentioned, some manufacturers don't like you adjusting them. This one off the Worcester, obviously they've got some tape on there which is basically saying, don't touch me. The little blue bit is a dust cap, so that's just protecting that part. On pre-mixed, there's no point testing the outlet pressure, because one of the other names for these gas valves are zero governors. It could be that when we test the outlet that we actually get a zero or a negative pressure, which doesn't comprehend, or it didn't used to me when I first heard about it. I thought, well, hang on, if we're getting burners and pressure, we should have a positive. But it's the way the gas valves work. It's all to do with the air-gas ratios in them. So on a pre-mixed burner, we always check the inlet pressure. So refer to your manufacturer's instructions again to make sure you've got the correct inlet pressure for the boiler to perform to specification. So that's a little bit about the SITs. So the last section that we're going to look at are gas adaptive gas valves. So the last gas valves we're going to have a look at are gas adaptive. What do we mean by gas adaptive? On the previous ones, we've had 2 or 3 possible solenoids. They open up to let gas through. The modulating solenoid adjusts to let gas through. So gas adaptive, the idea behind that is so that the gas is always burning at the perfect amount. The fan speed adjusts, and it's adjusted through the rectification signal, sending back to the PCB, and it measures how well it's burning. So it's always to get ideal combustion. So the first one that we've got here is a Bertelli gas valve. This come off the Baxi GA range. Now, it's got 4 connections on there, so 2 of them are for a solenoid and 2 of them for a motor. So that motor's a DC motor, so it's fine tuning all the time to make sure it burns as perfectly as it can. A little bit like a modern car engine with variable valve timing to get the most fuel economy out of it. So that's what gas adaptive is. This is a Siemens one. So again, we've got a solenoid and we've got a motor that's adjusting all the time. So coming back to the Bertelli one. Now, there's 4 connections on there, for 4 wires, a blue, a brown, a green and a white. Now, if I ask 90% of you guys which 2 connections were for a valve, which 2 were for the motor, you'd probably go brown and blue for one of them and green and white for the other, which is natural because when we're wiring a plug, brown's light, blue's neutral. However, it's not the case. So without the manufacturer's instructions and a coloured wiring diagram, or a wiring diagram that identifies, and a sheet there which tells you which pins and which connections, you probably get this wrong. So to check, we need to go across brown and white. So across brown and white, we've got a reading on there of 66 ohms, which if we look at the sheet, across brown and white, what we're looking for is 68 ohms, so we're there. The green and blue, 23.4, and in this case it's 25, so we're within tolerance, so that valve is correct. So it's really important when you're doing testing and checking that you make sure you've got manufacturer's instructions or access to that information. So just coming back to this valve, there's no adjustment, it's all done electronically. On the previous SIT gas valve, you could adjust those using an Allen key. With this one, it's all done electronically. So on these particular boilers, the adjustment was done. If any adjustment was necessary, you could fine tune it by going into parameters and pushing buttons on the front of the boiler. But one of the most important things when putting these gas valves in, and 1 or 2 occasions I had phone calls from installers who changed the gas valve and they couldn't get them to set up. One thing that they hadn't done is order a new injector washer. These particular gas valves come, or they have an injector washer. It's not a standard fibre washer, it's got an injector in the centre of it, and dependent on the output of the boiler, that washer was a different size. So if you do change one of these gas valves for any reason at all, make sure you get the appropriate injector washer to go with it. So that's gas adaptive. Possibly going forward with hydrogen mixed, this could be a way that we're going to go forward. I don't know, I'm not privy to that information. Anyway, I hope you've enjoyed today's video. I'd like to thank Alan again for making me look really professional. We have had comments that I don't stop for a breath. I do. This video's probably took us the best part of 2.5 hours to put together. It's probably a 10-15 minute video with all the cut and pasting. but we really enjoy doing them. Hopefully you guys have got a bit more insider knowledge. So until the next time, thanks very much for watching. Bye bye.
Thanks very much for that, Roy. I hope you found this video of some use. Please put some comments below, and if you want any more videos like this, then put some comments below, give us some feedback, let us know which bits of the videos you like, what you want more of, and we'll try and accommodate you best we can. Thank you once again to Viva Training Academy for allowing us to do these videos, and thank you to Roy. Having somebody of you know, so much expertise is just amazing, and it's really good to be able to share that with you guys as well. So as I say, please, if you could, thumbs up, like, subscribe, comment, all that good stuff. Thanks for watching.